Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, in this episode of AEEE training, we're going to be looking at some sample questions which are based on the format of the AEEE exam. So what we're going to do in this video is we're going to look at some of these questions and look at how to solve them effectively. So, let's start off with our first question. This one is from physics. Which of the following has the dimensionality of a farad? So what we're doing is finding out the dimensions of the unit farad. Farad is the unit for capacitance. So since we need to find the dimensionality of a farad, we usually use the 7 basic units for the dimensional analysis. So we'll have to write them in units, so like amperes, kilograms, meters, etc. So, how do we solve this question? Well, for that we need to find some way to relate capacitance with other quantities. For example, the capacitance in a capacitor is given as Q over V, where Q is the charge and V is the potential. So, if we were to look at the dimensions of capacitance, we would have to use the dimensions of charge, divide that with the dimensions of potential. Now, charge can be written as current multiplied by time, and both current and time are part of the 7 basic units. So therefore, we can write it as A times T, the dimensions of the numerator. Now, potential is described as energy over charge. So basically that means you'll have the dimensions of energy, ml squared t powered minus 2, over the dimensions of charge, which is at. So what we're getting is m l squared t powered minus 2 a raised to minus 1, t raised to minus 1 in the denominator. Now, all we have to do is to take the components in the denominator to the numerator, and we've got our dimensions for charge. So what we have now is m, which stands for mass. It was in the denominator, so it goes to the numerator, so you have m raised to minus 1. Length, we have L squared in the denominator, it goes to the numerator, so it becomes L raised to minus 2. Now, for time, we already have time in t raised to 1 in the numerator. We're taking t raised to minus 1 as well as t raised to minus 2 to the denominator, so they become t raised to 1 and t raised to 2 respectively. So when you multiply the whole lot of them, you'll get t raised to 1 plus 2 plus 1, which is t raised to 4. And finally, amperes, if you take a raised to minus 1 to the top, it becomes a. A times a gives you a squared. So therefore, the dimensions of capacitance are m raised to minus 1, l raised to minus 2, t raised to 4, a squared. So if you look at our question, you can see that there's only one option with a squared, and that is option A. So therefore, option A is the correct answer. So just by reaching here, you can get to the answer, but if you want to get it according to the options, you can write farad and then convert all the units here into their SI units, all the components here. So mass will be in kilograms, length will be in meters, time will be in seconds, and current would stay as amperes. So therefore, when you compare option A with the answer that we've got, it is very clear that option A is the right answer. So therefore, that's how we find out the dimensionality of units. So what we do is we find out what it is the unit for, then relate it to the 7 basic dimensions, and then from there we can use their units and then find out what's the dimensionality of that earlier unit, which in this case is farad. So option A is the correct dimensionality of a farad. Now let's look at another question. This one is related with vectors. The sides in meters of a box joining at the origin are represented by 3 vectors. Vector A is 4i, vector B is 2i plus 3j, and vector C is I plus k. We need to find the surface area of the box. Since we're dealing with a box, we need to find the total surface area. This is basic math. And the total surface area is represented as 2 times LB plus BH plus HL. So we need to multiply the length with the breadth, breadth with the height, and length with the height as well. So what we need to do is multiply A with B, A with C, as well as B with C. So how do we do it? Well, here we need to find the surface area of the box, so we need a scalar form. So basically we need to use the dot product. So the modulus of the dot product is multiplying the components and then add the components together. So here's how it goes. Vector A is 4i plus 0j. Vector B is 2i plus 3j. So what we do is 4 times 2, we'll multiply the I vectors together, and then we add the product of the j vectors together, which in this case is 0 times 3. So 0 times 3 is 0, so what we have is 4 times 2, which is 8. Similarly, if you look at the dot product of B and C, then you can write it like this. You have 2 times 1, because you have 2i and I respectively. There is no j in vector C, so therefore it'll be 3 times 0. And there is no k in vector B, so therefore that will be 0 times 1. So both of these become 0, so what we have, the modulus of that dot product will be 2. Finally, you have A dot C, which will give you 4 times 1, and since there's no k component for vector A, it'll be 0 times 1. So therefore what we have is 4. So we know that the total surface area is 2 times LB plus BH plus HL. We can write that down as 2 times AB plus BC plus AC. So the dot product is a scalar, so it's 2 times 8 plus 2 plus 4, which will be 2 times a 14, which is equal to 28. So therefore 28 meters squared, option B is the right option. The other options are incorrect because according to our dot product, the final answer turns out to be 28 meters squared. Now let's look at another question. This one is from chemistry. Now remember, the periodic table is not a part of it, it's just what I'm using to explain the answer. Which one of the following exhibits Schottky defect? Now the Schottky defect is a stoichiometric defect for ionic crystals. So what does that mean? It means that since it's a stoichiometric defect, both anions and cations are missing from the crystal, and yeah, it's for ions, ionic crystals. So therefore, there has to be a dipole moment. So there has to be a positive charge, partial positive and partial negative charge for, the components itself. So, how do we solve this question? Let's look at each of the products given. Let's look at each of the compounds given here. Silver chloride is a perfect example for the Frenkel defect. Now, in the Frenkel defect, it's an interstitial defect where the positive ion goes into the interstitial site between negative ions. And the reason why this works is because silver, if you look at silver and chlorine, you can see that silver is much less in size than chlorine because it's, a transition element, and chlorine is an anion. So if you check out their sizes, then chlorine is way bigger than chlorine is way larger than silver, so therefore it exhibits the Frenkel defect. So option D is incorrect. Next we have ferrous sulfide and nickel oxide. Both of these exhibit what we call the metal deficiency defect. So their crystals are less ionic. So therefore they exhibit the metal deficiency defect where the metal is missing. So therefore options A and C are incorrect. The right answer is option B, potassium bromide. As you can see, they are in the fourth period, and potassium is the alkali metal and bromine is the halogen. So usually between alkali metals and halogens, their crystals exhibit the Schottky defect because both of those ions will be missing from the crystal structure. If you look at the other, options here, all of them have their ions at different periods. Nickel, oxygen, iron, sulfur, and silver, chlorine. So again, you can see that. So therefore option B is the correct option here, potassium bromide. So they're in the same period. They exhibit the Schottky defect where both anions and cations are missing from the crystal. Now let's look at another question. Which one of the following is anti-ferromagnetic? Is it titanium oxide, nickel, oxygen, or ferrous oxide? Well, let's look at our options here. Ferrous oxide is what we call FeO. It's also called the iron 2,3 oxide. And the reason why that is because FeO is made out of two oxides, actually, Fe2O3 and Fe3O4. So because of it being a hodgepodge of oxides, it's actually what we call a paramagnetic substance. So what happens here is that it has a lot of these ions, it has a lot of these oxides coming in together, so all of them will have different dipole moments in different directions, so therefore it's paramagnetic. So option D is incorrect. It's not anti-ferromagnetic. The thing about anti-ferromagnetic is that they will have opposing dipole moments, which gives us a net dipole moment of 0. And that's what we're looking for. Option A, titanium oxide. Now, titanium oxide often exhibits what we call the metal excess defect. So because of that, and since it's titanium, titanium attracts to magnetism, and since in titanium oxide you have the metal excess defect, so it turns out to be a ferromagnetic substance. So therefore option A is incorrect. Option B, nickel. Nickel is also ferromagnetic. In fact, it's one of the few metals which are ferromagnetic on its own. The reason being that ferromagnetic itself means, being magnetized easily, and nickel, iron, and cobalt are some of the metals that do that. So option B is incorrect. That means option C, oxygen, is the right answer. It might not look like it at first, but if you were to freeze oxygen, it's found that solid O2 is actually antiferromagnetic. Again, of course, you have this recurring dipole moment where oxygen wants to grab two electrons, so therefore oxygen turns out to be antiferromagnetic in its solid form. So therefore option C is the right option. Some people say that ferrous oxide and titanium oxide are antiferromagnetic. However, titanium oxide is mostly found to be ferromagnetic because of the metal excess defect, and ferrous oxide is a hodgepodge of oxides, so it all turns out to be paramagnetic in the end. So therefore option C, oxygen, is the most appropriate answer. Now let's look at a question from mathematics. It might sound like one from physics, but there is a mathematical element to it. A car completes the first half of its journey with a velocity v1 and the remaining half with a velocity v2. Find the average velocity for the whole journey. Well, for that, we will divide the journey into two halves. Each half has a distance s, so the total distance is 2s. Now in the first half it goes with the velocity v1, for the second half it goes with the velocity v2. Now the formula for average velocity is total distance over total time. Now here, in As you can see, we don't know the total time yet, so we will find the time for both these halves. The time t1 will turn out to be the distance s over the velocity v1, and the time t2 will turn out to be the distance x over the velocity v2. So therefore, the total time would be t1 plus t2. So let's calculate average velocity. The average velocity will be 2s over t1 plus t2. So if you were to replace t1 and t2, you will get s over v1 plus s over v2. Now, remember that we have 2s over s by v1 plus s by v2. So let's take s from both of those fractions and take it as a common factor. So therefore, you have 2s over s times 1 by v1 plus 1 by v2. So you have s and s cancelled out. So what you have is 2 over 1 by v1 plus 1 by v2. So we can just, find the LCM and solve it. So you get 2 over v1 plus v2 over v1, v2. The product goes into the numerator because it's divided twice. So you have 2v1, v2 over v1 plus v2. So this is the average velocity. Now remember, over here, we find out that in this particular step, we can recognize that the average velocity here is represented as the sum of, basically it's not the sum, it's basically what we call a harmonic mean. So that means it's the mean of two elements from a harmonic series. So, and the reason why it's that, because in we find fractions of the denominator being added together. That's a classic sign that it's a harmonic mean. So therefore, average velocity is 2v1 v2 over v1 plus v2. We got this from the harmonic mean of 1 by v1 and 1 by v2. I mean, harmonic mean of v1 and v2. So therefore, if you want to answer this question, then the answer is option D, 2v1 v2 over v1 plus v2. The others are incorrect because we don't know if there are equal distances. We just assume that they have velocities. So therefore, the best method to do is use their harmonic means. So options A, B, C are incorrect. Option D is the only one that gives us the idea that this is a harmonic mean. So the average velocity of the car for this whole journey would turn out to be the harmonic mean of the two velocities, and that will be 2v1 v2 over v1 plus v2. Now let's look at another mathematical question. Let T of n denote the number of triangles that can be formed using the vertices of a regular polygon of n sides. If the equation T of n plus 1 minus T of n equals the number 10, then find the value of n. So, how do we solve this question? Well, the regular polygon has n sides. So any regular polygon with n sides would also have n vertices. Now, why would we need to find the number of vertices? Because the first part of the question says Tn is the number of triangles formed using the vertices of a regular polygon. Now, a triangle has 3 vertices, which is why it's called a triangle. So therefore, we know the number of vertices that has to be chosen. We know the total number of vertices that are present in the polygon. So we can safely assume that T of n, or the number of triangles formed from the vertices of a regular polygon, is in fact a combination. It's NC3. So we will consider T of n as NC3, so therefore, using that same vein, T of n plus 1 will be n plus 1 C3. So we have this equation, T of n plus 1 minus T of n equals 10. So what we're going to do is replace T of n plus 1 and T of n with the combinations. So T of n plus 1 is n plus 1 C3 minus T of n is NC3. That gives you the value 10. We need to expand these combinations in order to get our answer. Now, the easy way to represent a combination, since we have n and r here, so we will write, since it's NC3, n plus 1 C3, we will write the first three terms, n plus 1, n, and n minus 1. Divide that with the last three terms, which is 1 and 2 and 3. So we multiply those terms. For NC3, it'll be n times n minus 1 times n minus 2 over, again, 1 times 2 times 3. Now this will be equal to 10. So what are we going to do? We need to take the common factors out of this. So here n is common, n minus 1 is common, the denominator is also common. So we'll take n times n minus 1 over the product, which is 3 times 2 times 1, that's 6. And then inside the bracket, you will have n plus 1 minus of n minus 2, which is equal to 10. So let's solve that. Let's solve the bigger bracket. So n plus 1, when you put minus inside the bracket, you'll get minus n plus 2. That equals 10. So n times n minus 1 over 6. And then inside this bracket, n and n gets cancelled out. 1 plus 2 gives you 3, which will be equal to 10. 3 cancels out 6. The remainder is, the quotient is 2. So what we have in the equation is n times n minus 1 over 2 equals 10. So this implies that n times n minus 1 will be 10 times 2. That will be 20. Now, we need to represent 20 in such a way that they are two adjacent numbers. So when you look at 20, you have 120, 210. You can't do it with 3. You have 4, 5. And that's it. Now, if you look at the pair 4, 5, you see that 5 minus 1 is 4. So 20 can be represented as 5 times 4. So since we have n and n minus 1, multiplying n and n minus 1 gives us 20, it has to be 5 and 4 respectively. So therefore, from here, you'll have n minus 1 equals 4. That means n will be equal to 5. So the value of n, or the number of sides of the regular polygon, is 5. So therefore, for this question, the value of n is option A, 5. The other options will be incorrect because when we use the combination, when we use permutations and combinations for this question, we find out that the answer is 5. So in this particular question, we're taking triangles out of a pentagon because we have 5 sides. And if you take the number of triangles from a hexagon and, subtract it with the number of triangles that you can take from a pentagon, the value will be 10. So therefore, we can safely say that option A, 5, is the right answer. Now that concludes this episode of AEE training. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to get the latest updates from our channel, then please don't forget to hit the bell icon present below the video. So until the next webisode, take care, stay alert, bye-bye for now.